Hello viewers, welcome to my channel. We are still on the topic surd, but today we'll be looking at the subtopic conjugate surds. If you're joining us for the first time, we've worked on other subtopics of surd like the reduction of surd to basic form, expressing surd as a single surd, addition and subtraction of surd, multiplication and division of surd, rationalizing the denominator of surd, and surds in brackets. I'll be dropping the link to this video in the description box below. Do well to look at them so you don't miss out on this topic. Now let's start. Conjugate surd. So what are conjugate surd and what does the word conjugate mean? So we have two binomial surds. When we talk about two binomial surd, the word binomial means surd that has two values. More like, let's say we'll have root 3 and then we'll have root 2. So we have to join them with a sign, either the plus or minus. Plus or minus. So this surd here is a binomial surd. This one is also a binomial surd because it has two values. Unlike the single surd like root 3 and then separately root 2. This is a single surd. This is a single surd. So when we're talking about conjugate surd, we're working with the binomial surds. So two binomial surd are said to be conjugate of each other. They are said to be conjugate if their product yields a rational number. So let's take this again. Two binomial surds are said to be conjugate of each other if their product yields a rational number. So it's saying that if this binomial surd and another surd, it said two binomial surds, two. So if this one and another binomial surd are said to be conjugate if their product. So if I take this binomial surd and multiply it with another binomial surd, if I multiply them together and get a rational number, then they are conjugate of each other. And what do we say about surd? It says that whenever a surd is in this radical form, that's root 3, then we have here root 2. It is called irrational surd or irrational number. They are irrational number. So now for we to now get them to be a rational number, we should get something like either 3 plus 2 or 3 minus 2, just something like this. So rational number should be working with whole numbers. So 3 plus 2 is going to give us 5. So this is a rational number. But when it is in this radical form, that's the root 3 plus root 2, it is irrational number. So the purpose of getting the conjugate is to transform this binomial surd to a rational number. So now before we can actually work with this conjugate, I would love us to look at the difference of 2 squared. So let's work with letter. So let's say we have P plus Q. I know difference of 2 squared, the sign from plus, it's going to become minus. So P minus Q. I want you to observe that the letters are the same. P plus Q, P minus Q. That's P, P, Q, Q. The only difference here is the what? The sign. Here we have a plus sign. Here we have a minus sign. So this is one thing we should observe on the difference of 2 squared. So now I would love us to expand this variables. I would love us to expand these values. Now for we to expand this, we'll have P times P, which is going to give us P squared. And here we'll have P times minus Q. P times minus Q is going to give us minus PQ. Now here we have plus Q times P. It's going to give us plus PQ. And then we'll have plus Q times minus Q, which is going to give us minus Q squared. So you agree with me that minus PQ plus PQ are opposites. So in algebra or even in numbers, if we have opposite sign of the same values, we have to just take them away because it is 0. It's more like saying minus PQ plus PQ. That's PQ minus PQ is 0. So let's just cancel it out. Now we are left with P square minus Q square. So now instead of this initiative of difference of 2 square, I would love us to introduce it in surd. So now instead of using just these are rational numbers, that's rational, let's say they are whole numbers. So instead of using this whole number, let's now introduce it using the radical form of the P and Q. The radical form will be, let's say we have roots P plus roots Q, then root P minus root Q. So now these values are in surd form. They are irrational numbers. So now exactly the way we expand this, let's expand this one too. So now we'll have This times this is going to give us root p square. Then we'll have root p times minus root q is going to give us minus root pq. Now plus root q times root p is going to give us plus root pq. And then we'll have plus root q minus root q is going to give us minus root q square. You know it's the same letter, q times q, q square, and then here we have p times p, p square. So the same thing applies here. Minus pq, that's minus root pq plus root pq. These are opposite signs of the same value. So when we take them away, it is 0. So now we are left with root p square. Square roots cancel square. We'll be left with just p. The same thing will apply here. Square root cancel square. We'll be left with q. It's just like saying the square root of a number. When you look for the square, it will still be the same number. Like saying the square root of 5 square. You know 5 square is what? 25. What's the square root of 25? It's going to give you 5 back. So the square root of a number, if you look for its square, you get the same number back. So the square root of p square is p minus, you know there's a minus sign here. There's a minus sign here. Now the square root of q square is q. So now if you look at this now, if you look at this p minus q is a rational number. That means it is now in the form of whole number. We no longer have this radical, or let's say the square root. We no longer have them. So now if you notice, this is a product of binomial. It says two binomial surds. So this is a binomial surd, this is a binomial surd. So now the two of them, if you look for their product and it gives you a rational number, here is a rational number. It gives me this rational number. So we can agree that they are conjugate of each other. They are conjugate of each other. Now allow us to introduce a simple method of expanding this surd in case we want to solve other conjugate of surd. Instead of using this expansion of multiplying this to this, this to this. So just observe that whatever you get here, it must yield to 0. Look at, when we look at this minus pq plus pq, it gave us 0. So we're now left with p square minus q square. So that's saying if we have root p plus root q, and then we'll have root p minus root q. You can just pick this times this, which is root p square, and then pick this one, this times this, minus root q square. Easy. Just pick the first letters together. Root p times root p will give you root p square. Now pick the last one together. Plus root q minus root q is going to give you minus root q square. Then if you use the method of saying square root cancel square, you are left with p minus square root cancel square, you are left with q. So we have the same answer here. We have the same, this is the same and this is the same. So instead of expanding this and at the same time you still get 0 here, just use the method and get the p minus q. So now we can agree that two binomial surds are said to be conjugate of each other if their product use a rational number. So therefore, we can agree that root p plus root q and root p minus root q are conjugate of each other. Yes, they are conjugates of each other because their product gave us what? A rational number. This is a rational number. Their product gave us a rational number. So I want us to observe something. For conjugate surds, the values are always the same. The only difference is the sign. Here we have root p, we also have root p here. Here we have root q, we also have root q here. So if we're looking for the conjugate of root p plus root q, it is root p minus root q. The only difference is the sign. So now if we say look for the conjugate of root p minus root q, the conjugate will be root p plus root q. The same thing applies. Look for the conjugate of root p plus root q. The conjugate will be root p minus root q. So now these two surds are conjugate of each other because when we look for their product, we got p minus q, which is a rational number. So now let's progress. Examples. Write down the conjugate of each of the following. So just like what we did with letters P and Q, that's root P and root Q, here we are going to be working with numbers. So if you observe there, we said if you have two surds, the surds remains the same. The only difference is what? The sign. So for conjugate, if I have minus here, my conjugate of this surd is going to be what? Plus. Here I have plus, the conjugate of this surd is going to be what? Minus. Remember, the values remains the same. You're not changing the values. So now let's look for the conjugate of this surds. So for number 1, we'll have root 5 minus root 3. The conjugate will be root 5 plus root 3. So for number 2, we'll have root 3 plus root 2. The conjugate will be a negative. Because of this plus, is going to be minus. So root 3 minus root 2. So for number 3, the conjugate is 4 root 2 plus 5 root 5. And then for number 4, which is the last here, it's going to be 1 minus root 2. So these are the conjugates of this sort. Just write the same values, change the sign. From minus, it's going to be plus. From plus, minus. From minus, plus. From plus, minus. So now let's move forward. Here, we can multiply binomial surds by their conjugates to get a rational number. Of course, that's what we did here. We multiplied this binomial surds, two binomial surds. So we multiply these surds, root p plus root q, root p minus root q. We multiply them together and it gave us p minus q, which is a rational number. You know, I say rational number can be whole number or even fraction, but they must be whole. No surds, no square roots. So now, let us, exactly what we did here, let us apply it there. And remember I said if you have surds like this, instead of expanding them one after another, you can just multiply the first letters together and then the second letters together. That way you get a rational number. So now let's work with number 1. It says we can multiply binomial surds by their conjugates. So each of this surd here, we have to look for their conjugates. Then after we get the conjugate, we multiply them together to get a rational number. So let's start. We have 2 plus root 3. What will be the conjugate of this? The conjugate is 2 minus root 3. So now let's multiply these two binomial surds together. When we multiply these binomial surds together, then we get what? A rational number. So just like I said, multiply this first one with this. So 2 times 2 is going to be 2 square. And then multiply this times this. It's going to give us minus root 3 square. So 2 square is 4. Then square root cancel square. We have minus 3. 4 minus 3 is what? 1. Now for number 2, we have 2 root 3 minus 4. So the conjugate of this surd is going to be a plus sign. 2 root 3 plus 4. Now let's take the first one, this times this. So we have 2 root 3. 2 root 3. So we have to take the whole number first before the radical number. So 2 times 2 is going to give us 2 square, and then we'll have our roots 3 square. You can join them together by writing 2 root 3, then in a bracket all square. You're going to get the same thing. So now we'll have minus 4 times 4 is what? 4 square. So now what we'll have is 2 square is what? 4. Now square roots cancel square. We have times 3 there. So it's now 2 square 4. 2 square is 4. Then there should be an invisible times here. So times this 3 remaining, which is what we'll have here. Then we'll have our minus 4 square is what? 16. Now this is equal to 4 times 3 is 12. Then 12 minus 16 is going to give us minus 4. So this is now a rational number. So now if you observe, with the conjugate of this source, we've been able to get a rational number. That's with the product of the conjugate. Looking for the product of the conjugate, we've been able to get a rational number. Now let's do the last one here, number 3. For number 3, we have 3 root 2 plus root 3. Now what is the conjugate of this surd? The conjugate of this surd is 3 root 2 minus root 3. So now we'll multiply this together, we'll get 3 square root 2 square. Then we'll have minus, when we multiply root 3 times minus root 3, we'll get root 3 square, minus root 3 square. Now 3 square is what? We'll have 9. Then square root cancel square, we have times 2 there. So we have minus square root cancel square, we have 3. Now 9 times 2 is what? 18 minus 3. 18 minus 3 is going to give us 15. So this is the answer for these questions. This is the answer for these questions. So now let's move to the next part. So rationalizing the denominator. Rationalizing denominator. So on the description box, you will see a link to rationalizing the denominator of surd, but that was when we did division of surd, whereby we were rationalizing with a single surd. But in this place, we are going to be working with binomial surds. Binomial surds. So now, how do we rationalize these surds? How do we rationalize this surd? Now, however, if the denominator of a surd is in the form, if the denominator is in the form, that means if the denominator has binomial surds, here we have root p plus root q. These are binomial surds. The denominator can be rationalized by multiplying the numerator and denominator by its conjugate, which is root p minus root q. It's just like saying, let's say we have a over root p plus root q. And now we say if the denominator is in this form, root p plus root q, that we should multiply the numerator. He said the denominator can be rationalized. That means this denominator can be whole numbers, can be rationalized, can be a rational number by multiplying the numerator and the denominator by its conjugate. So what is the conjugate of root p plus root q? The conjugate is root p minus root q. So we're going to apply this to the numerator and the denominator. So times. So now we've been able to multiply this numerator a times root p minus root q, and then the denominator root p plus root q, we're able to multiply it to root p minus root q. So conjugate the denominator, find the conjugate of the denominator, then multiply the numerator and denominator by that conjugate. That way we can get here a in bracket root p minus root q all over the denominator. Remember that root p plus root q, if we multiply it by this one, so root p plus root q, multiply by the one here, root p minus root q. Root p minus root q. So we've been able to multiply this denominator. We've been able to multiply this denominator in the first slide. So which gave us a rational number, right? P minus q, that's what we got. So therefore you can say this is a root p, a times root p is what? A root p. A times root p, a root p, then a times minus root q, minus a root q, all over the product of this is what? P minus q. So you can see that the denominator has been what? Rationalized. This denominator has been rationalized. So now with this method, with what we did here, we'll be able to solve number 1, 2, 3, and then number 4. So now let's proceed. So we have number 1 to be 3 all over 3 minus root 2. So for number 1, we have 3 all over 3 minus root 2. So the first thing we have to do is to look for the conjugate of 3 minus root 2. The conjugate of 3 minus root 2 is 3 plus root 2. So now we have to multiply the numerator and the denominator by 3 plus root 2. So that is times 3 plus root 2 all over 3 plus root 2. Remember, you are multiplying numerator and denominator by 3 plus root 2, the conjugate. So now, the first thing we'll have to do here is to bring them together. We have to bring them together. So this becomes 3 times, bracket means times. So 3 times 3 plus root 2. Then all over, I'll bring the denominator together. 3 minus root 2. 3 plus root 2. So I hope you understand what's happening here. 3 minus root 2 times 3 plus root 2, you bring them in brackets, which also means times. The numerator, 3 times 3 plus root 2, you bring them in bracket 3 plus root 2, which is what we have here. So now we have to clear this bracket. So 3 times 3 is going to give us 9, and then we'll have 3 times plus root 2. It's going to give us plus 3 root 2. Now for the denominator, 3 times 3 is what? 9. Or let's just write it this way. 3 times 3 is what? 3 square. And then we are going to bring this together, minus root 2 square. So for the numerator, we'll have 9 plus 3 root 2 all over the denominator. 3 square is what? 9. Minus square root cancel square. We are left with 2. So our answer here is 9 plus 3 root 2 all over 7. All over 7. We can decide to leave our answer this way, or we bring the denominator like 1 all over 7. We bring the denominator this way in a bracket 9 plus 3 root 2. So you can decide to leave your answer this way or this way, whichever way, they are the same thing. It's just like saying 1 times all this will give you 9 plus 3 root 2. Then all over 7, which is the denominator, all over 7. So whichever way you leave your answer, they are correct. Now let's move to question number 2. So for question number 2, we have root 3 plus root 5 all over root 3 minus 2 root 5. So the first thing we have to do is to look for the conjugate of the denominator. The conjugate is root 3 plus 2 root 5. So we're going to multiply the numerator and denominator by this conjugate. So root 3 plus 2 root 5 over root 3 plus 2 root 5. So bring the numerators together. Root 3 plus root 5 in a bracket, root 3 plus 2 root 5 in a bracket. Now for the denominator, we'll have root 3 minus 2 root 5 in a bracket, root 3 plus 2 root 5 in a bracket. So now we have to clear this bracket for the numerator and denominator. So let's start with the numerator. Root 3 times root 3 is going to give us root 3 square. And then we'll have root 3 times 2 root 5. Root 3 times 2 root 5. There's a plus sign here. So plus 2 root 3 times 5. We are going to put this surd under the same radical sign. So root 3 times root 5 is what we have here, 3 times 5. Then we'll have our 2, which is a whole number. This is it here. So 2 root 3 times 5. If you're finding this difficult, you have to look at the multiplication of surd. You understand this better. The link is at the description box, so check it out. So now we move to the next one, root 5 times root 3. So plus root 5 times root 3. Plus root 5 times root 3 is going to give us plus, let's put it under the same surd also, 5 times 3. And then the last one, plus root 5 times 2 root 5. So which is going to be plus 2, the root 5. We have root 5 here, so root 5 square. I hope you understand what's going on here. So now let's do all over the denominator. The denominator will have to do, the denominator is the conjugate. So remember, the denominator is always the conjugate. So instead of expanding everything and getting 0 at the middle, just do the first one times the first one, the second one times the second one. So now let's do it. So we have root 3 times root 3 is going to give us root 3 square. And then we'll have minus 2 root 5 plus 2 root 5, which is going to give us minus 2 square, then root 5 square. So root 3 square, we are going to do square root cancel square, we are left with 3. And then here we'll have 2 roots. 3 times 5 is 15, plus 5 times 3 is what? 15. So plus root 15 plus 2. So square root cancel square, we are left with 5. So 2 times 5 for the numerator. And now for the denominator, we'll have square root cancel square, we have 3 minus 2 square is what? 4. Square root cancel square is what? 5. So times 5. So now we have 3 plus 2 root 15 plus root 15. It's more like saying there's an invisible 1 here. So 2 root 15 plus 1 root 15 is going to give us 3 root 15 plus 2 times 5 is what? 10 all over 3 minus 3 minus, remember these two are together. We got them from 2 square, which is 4, square root cancel square, which is 5. They are together. So 4 times 5 is what? 20. So now we have, let's collect like terms. Collection of like terms, you can see this part of this topic on addition and subtraction of surd. Check the description box for this video also if you're joining us for the first time. So now, collecting like terms, we have number to number, then this surd will stay on its own. The one with the radical sign will stay on its own. So 3 plus 10 is coming together. So collecting like terms, these two will come together, which is 3 plus 10, and then we'll have plus 3 root 15. So for our denominator, we have 3 minus 20, which is minus 17. So our answer is 3 plus 10 is what? 13 plus 3 root 15 all over minus 17. You can decide to leave your answer this way, or let's bring the minus 17 out. So it's going to be minus 1 over 17. In a bracket, we have 13 plus 3 root 15. So whichever way you decide to leave your answer, they are correct. So this is the answer for question number 2. Now let's move to question number 3. For question number 3, we have 1 all over 2 root 3 plus root 5. 2 root 3 plus root 5. So the first thing we have to do, we have to look for the conjugate of the denominator. So the conjugate of the denominator is 2 root 3 minus root 5. 2 root 3 minus root 5. So we'll multiply the numerator and denominator by this conjugate. 2 root 3 minus root 5 all over 2 root 3 minus root 5. So now let's bring them together. Here we'll have for the numerator 1 times all of this. You know, in numbers, anything multiplied by 1 is the same thing. So 2 root 3 minus root 5 times 1 is going to give us the same 2 root 3 minus root 5 all over, we'll bring the denominators together, 2 root 3 plus root 5 bracket 2 root 3 minus root 5. So clearing the bracket at the denominator, we are going to have, for the numerator, let's maintain the 2 root 3 minus root 5 all over. So 2 root 3 times 2 root 3 is going to give us 2 square root 3 square. And then plus root 5 times minus root 5 is going to give us minus root 5 square. So for the numerator, we're going to keep maintaining that same thing because they are not like them. They are not like them. Here we'll have root 3, root 5. So they are not like them. It's just like saying we have 2x minus y. They are different. You cannot multiply them together. So you have to maintain what you have at the numerator. You have to keep writing that. So 2 root 3 minus root 5, denominator all over. 2 square we have 4. times square root cancel square, so times 3 minus square root cancel square, which is 5. So now we're going to have 2 root 3 minus root 5 all over 4 times 3 is what? 12 minus 5, which is going to give us 2 root 3 minus root 5 all over 12 minus 5 is 7. So you can decide to leave your answer this way, or you say 1 all over 7 bracket 2 root 3 minus root 5. They are the same thing. So now let's move to the last question for this video. So here we have 1 all over 1 minus root 3, then square. So this question is different from what we've solved so far. It's different from the number 1, 2, and 3. So what this means is, if we have this kind of question under surd, we have to first tackle the denominator. The denominator says square. We have to first look for the square of this binomial surd. We have to first look for the square before we rationalize. You know, rationalizing the denominator says we have to make the denominator a rational number. If you notice, this is what we've been doing. This is a rational number. 7 is a rational number. 17 minus 17 is a rational number. 7 here also is a rational number. So I hope you remember the purpose of rationalizing the denominator, which is to make the denominator a rational number. So meaning we have to look for the square of this. After we've gotten the square of this, we can now rationalize to get a rational number at the denominator. So now, square in mathematics means you should multiply that number by itself. It's just like saying 5 square, which means multiply 5 by itself. Then when we say a square, multiply a by itself. So now we have 1 minus root 3 square. It means multiply 1 minus root 3 by itself. So now we have to focus on the denominator now. Let's maintain what we have at the numerator. We have to leave what we have at the numerator and focus on the denominator. So this is equal to 1 all over multiply 1 minus root 3 by itself. 1 minus root 3 times 1 minus root 3. So now let's expand the bracket in the denominator. So 1 all over 1 times 1 is what? 1 square, which is also 1. And here we'll have 1 times minus root 3. It's going to give us minus root 3 because any number times 1 is any number. 100 times 1 is 100. 200 times 1 is 200. A times 1 is A. So 1 times minus root 3 is minus root 3. So here we'll have minus root 3 times 1, which is also going to give us minus root 3. And the last one here is minus root 3 times minus root 3. Minus times minus is what? Plus. Plus, then root 3 times root 3 is going to give us root 3 square. So now focusing on just the denominator, we have 1 all over 1. Here we have minus root 3 minus root 3. Minus root 3 minus root 3, they are the same thing. They are the same number, so they are like 10. Minus root 3 minus root 3 is just like saying minus 1 root 3 minus 1 root 3, which is going to give us minus 2 root 3. In algebra, we can say something like minus x, which is something like minus 1s, which is giving us minus 2x. So the same thing applies here. Minus root 3 minus root 3 is minus 2 root 3. Then the last one there says plus square root cancel square, we have 3. So now we have 1 all over, for the denominator, 1 and 3 are like 10 because they are whole numbers. So we bring them together, 1 plus 3, and then we'll have our minus 2 root 3. So our final answer here is 1 all over 1 plus 3 is what? 4 minus 2 root 3. So we've been able to look for the square of this. We've been able to look for the square of the denominator. So now that we've gotten the square, we can now rationalize this denominator. So what we're going to be working with now is 1 all over 4 minus 2 root 3. So now this is the new surd we're going to be working with. This is the new surd we're going to rationalize. So this denominator 4 minus 2 root 3 is what we're going to rationalize. So now we'll have 1 all over 4 minus 2 root 3. So 4 minus 2 root 3. What is the conjugate of 4 minus 2 root 3? The conjugate is 4 plus 2 root 3. So now we have times 4 plus 2 root 3 all over 4 plus 2 root 3. So for the numerator, 1 times 4 plus 2 root 3 is going to still give us what? 4 plus 2 root 3. Anything times 1 is the same thing. So here we'll have 4 plus 2 root 3 all over the denominator. 4 times 4 is what? 4 square. And then minus 2 root 3 times 2 root 3 is going to give us minus 2 square root 3 square, because we have 2 times 2 root 3 times root 3. I hope you remember that. Then the minus sign, because minus times plus is what? Minus. So the reason why we're expanding this way, remember, it's because of the denominator is what? The conjugate. The denominator is the conjugate. So we have equal to 4 plus 2 root 3 all over 4 square is what? 16, minus 2 square is 4, then square root cancel square, we have times 3. So this is equal to 4 plus 2 root 3 all over 16 minus 4 times 3 is what? 12. So our answer is 4 plus 2 root 3 all over 16 minus 12 is going to give us 4. Now, one thing we observe here now is that 4 plus 2 root 3 all over 4. We have something in common in the numerator. So there is 4 here, there is 4 here. There is 2 here, and there is also 2 in 4. So we can decide to split this. We can decide to split this to the separate fractions that have the same denominator. So we are going to have 4 over 4 plus 2 root 3 over 4, which is 4 all over 4 plus 2 root 3 over 4. So 4 cancel 4 is what? 1. So our answer is 1 plus, then here we have 2 here, 1. 2 in 4 is what? 2. So we have 1 times root 3 is what? Root 3 all over 2. So this is the answer. 1 plus root 3 over 2. Now we've gotten the answer for question number 4, and this is the last thing we are doing for today. Thank you for joining me till this point. Thank you for your precious time. So if you have any question concerning surd and its subtopics, I mentioned some subtopics earlier that we've done. You'll find the link to those videos in the description box. So if you have any question concerning all the subtopics we've done, add this one to it, conjugate of surd, to the subtopics we've done so far. Drop it at the comment section. I will definitely respond to you. Yeah, I'll respond to your questions. So thank you very much for joining me today. See you in my next class. Bye.